you should download this app actually. This Crop Darpan app on your smartphone. So just you go to web and just you say Crop Darpan. What you have to do is that just go to Google. It is. What is this? Go to Google and Crop Darpan app. You just say Crop Darpan app. You can say agree. So you will get this logo actually, or you can show images and you get this logo. This is my app. It is available actually from this is the Google Play Store actually. It is also available on Apple Store also. So you download that one, and I'm going to talk about this app actually, how this app has been developed. It is there actually for last 6 years actually. I'm going to talk about this app actually. Otherwise, also you can go to this cropdarpan.com website also. It is available. So, so my research area is that I work in Data Science and Analytics Center. I also work at IT for Agriculture Center at IIIT Hyderabad. My main area is the data mining, web mining, biomining, data systems, system building. So what I was doing is that I started with my research with database systems. Basically, I worked on concurrency control algorithms. Later on, all database researchers started work on data mining actually, because data mining happened because of collection of data. I also started data mining research. Then after doing postdoc at Japan and I returned to India, I'm trying to extend some system building ideas from database systems and operating systems, data mining, to build the systems to help farmers. So help farmers. I'm going to share my experience of building these systems. What are the failures? How I refined? How I could build about Crop Darpan. Nowadays, I'm working on, in addition to data mining, data science, we call it. I'm working on IT for law and IT for bioinformatics, in addition to data mining research. So the presentation outline is as follows. So first I cover introduction. I built 3 systems for farmers. First I built eSagu system, which took about 6 years. I started in 2002 after coming back to India. Based on the feedback, I have built village level eSagu system. Based on the feedback of both systems, I conceived the Crop Darpan system. I will also list out some of the other problems for you to work. If somebody wants to do PhD or research, it doesn't matter which background you are. And definitely, I hope you will find this talk interesting. Let us see about Indian perspective. This is the picture about the percentage of population living less than $1 a day, $1.25 a day. This is 2009 picture, but now you can say $2, whatever it is. So all these blue colors, America, Europe, everything, they are actually under 2% are living less than a dollar. It means they are very rich kind of thing. And there are African countries, some of them, they are 61 to 80%. India case, 41 to 60% earn less than a dollar a day. This is very serious, actually. This is very serious. You might see you can walk in the Jabalpur or somewhere. We have a lot of poverty. Poverty means not that they don't have clothes or shelter, but other kind of poverty. They are unable to sustain the living. Always trying to making a lot of efforts to even find the food also. You can go to Jabalpur or any other city, a lot of people wait for the labor, daily wages. So this is the core problem we have taught us. All those, each individual who is sitting in the audience. This is the research problem we have taught us. In India, 41 to 60% earn less than a dollar a day. Less earning is leading to illiteracy. They don't go to school. If they don't go to school, they don't get skills. As a result, they don't get jobs. They don't earn sufficient money. They don't eat well. As a result, they suffer from malnutrition. I hope you don't know, large percentage of women and suffering from vitamin A deficiency, pregnant women. I got other slides I'm not covering because I have to cover 20-year summary in this, talk. So very unfortunate situation. We are saying India is growing, but in the bottom, we have a significant problem, development problem. The challenge for you and me and everybody who will consider themselves as educated, how to bring this population out of poverty. In other words, what kind of system you have to build to bring this population out of poverty? That is a research question. On the other hand, if you see right side graph, mobile phone subscribers per 100 happiness 2007 statistics, now 2025. Everybody has a smartphone. Not only mobile phone, they have smartphone. 5 to 6,000, you are getting a smartphone. So almost all population, we can say, have a smartphone. It means that also the good part is that the infrastructure is improving. Bandwidth is improving, cost is reducing. And there's opportunity to build mobile-based systems to help everyone. So we have to explore mobile-based systems, smartphone-based systems, in whichever area it is possible. And try to make an effort to build a system to bring population out of poverty. What should we do now? For example, left side box you see, there's agriculture technology. These are there actually because last 2 decades, even 2 centuries, few centuries back, earlier kings ruled, mafia ruled, anybody ruled. You can't escape these technologies. Even Afghanistan also, they have to do these things. Agriculture technology, education methodology, medical technology, artisan technology, employment generation, resource distribution, and efficient governance. So these are the technologies that are useful to improve the life, quality, life, quality of life. But right side, what is happening in India? We got rural and urban poor, uneducated farmers, unemployed youth, undernourished people having little incomes. So these left and right boxes are there actually. What is the new thing? ICTs, internet and mobile networks, decision support systems, data science and artificial intelligence. And these comes with parallel access, online access, information service framework, cloud and big data. So these are the new opportunities. What should we do? We have to extend these ICTs to improve the performance of these livelihood technologies. So he is doing agriculture, you are doing computer science. You have to collaborate, you have to talk to each other. You work in different manner, they work in different manner. But they are near to the problems. These people, agriculture, they deal with real problems. Education, deal with real problems. Medical, they deal with the real problem. But we are not dealing with the real problems. ICT researchers. We are somewhere like a operating systems and database system. Database system face the client. Your operating system doesn't face the client. Operating system, on the top of operating system, you install some application which faces the client. Similarly, ICTs should play a background role to these technologies. What kind of role can play? Where can how it can be improved? For that, you have to study these technologies. You have to study these technologies. So for that, you have to collaborate with one of the expert here. Then you have to read some of their papers, your paper they have to read and try to identify some serious researcher who wants to do same thing and start collaboration. Unless you collaborate, we can't build systems to serve this population. Another interesting point is that the madam told that there are some other background, non-computer science background in the audience. So this ICT box can be replaced with mechanical engineering technologies, civil engineering technologies, chemical engineering technologies. So you can pose similar problems. How the modern chemical engineering to improve performance of these, mechanical engineering will improve performance, civil engineering will improve performance. So in this way, you will get a lot of research problems. Everybody has a role to play. So this is the framework one has to work. So what I did was that I tried to extend the data science technologies, database technologies, and web technologies to build the systems to help the farmers. So one of the agenda for that, then again, how I got motivation. 20 years back, I read one research paper written by one of the famous database researcher. He said that what is the research agenda for database researchers? computer science researchers. But 20 years back, 1990s, 94, 98, the Google systems are already built. Google is built, Yahoo is built. They said that we built a search engine. What should we do in future? So one of the research problem it was posed was that creation of personal information systems. What is personal information system? So 20 years back, it was assumed that after 20 years, everybody has a personal information device called a smartphone now. The personal information system should deliver useful information to each and everybody regularly. That information to help the individual to sustain himself, means to bring, bluntly speaking, to bring more money to his pocket. So you have to understand life cycle of each individual, profession of each individual, and try to extract whatever the information that is available on the web, available on other people, and try to provide that. So that is the thing. So research agenda is that I asked a question. The question is, what is the personal information system for a farmer? For example, can we build personal information system to provide agricultural advice to each farm? Provide veterinary advice for each animal? Provide health advice for each individual? Provide literacy to each individual? Empower or provide employment skills to all population? So these kind of services we have to generate. Now let us come back to farmer. Since I am from a farming family, then I said that what is the personal information system for a farmer? By considering Indian context. So I'm a farmer of India. What I want? I'm a farmer of India. I own 2 to 3 acres. So most of the farmers are small farmers in India. The system which was built in US by considering big farming situation cannot work in India. I'm illiterate or functionally illiterate. So even I know how to read and write, don't consider that seriously because I don't know agriculture science. What farming needs? Farming needs water. Each farm requires water. So that is a political solution. The government should allocate budgets to harvest water. Need finance to each farm. Government is making efforts to provide finance each farm. You have to encourage banks and financial institutions to provide credit. First and two are research problems, but I am not solving it. There are hundreds of problems. A researcher cannot take up all the problems. Third is about personalized advice. I said that farmers need knowledge to each farm to reduce crop failure and low income risk. For example, consider India, millions of farms. I said that every farm a piece of land, 3 to 4 acres, you can say, requires some knowledge every month or every 10 days, agriculture advice to improve productivity and reduce failures. Are we doing that? We are not providing farm specific advice in India, but that is a requirement. What are we doing? We are running radio based system, video based system, website based systems. Even recently, I have read a research paper saying that most of the farmers, they have some problem, they have to go to pesticide vendor and following whatever pesticide vendor says. A lot of issues are there. So the existing systems are generalized, means that they generalize the situation. Every district facing a problem. If this is the weather, do these things. This is the pest, do these things. But farmer doesn't know whether his farm is facing the same problem or not. What he wants, what farmer wants. Farmer wants advice to his farm. What should he do? Is not generalized advice. But do we have a knowledge? Yes, we have a knowledge. Given a crop situation, given a crop problem, agriculture expert knows what is the problem. What is the solution? But farmer doesn't know. So we have a knowledge, means solution to the problems with ICAR lab, some of the scientists sitting in the audience, they know what is the solution, but farmer doesn't know. So I pose this problem as knowledge dam problem. Mean that suppose we build a Bakranangal or Nagarjuna Sagar dam, forgot to dig the canals, water will not flow. Similarly, we got a wonderful scientist with the universities, with ICAR labs, but farmers are practicing old practices. Sometimes they are not applying what they want, what they are supposed to apply. So the statement is that we do not have knowledge canals for each farm for flowing knowledge like water. So actionable knowledge should flow to each farm of India every 10 days. So the research question is, we have agriculture knowledge dams like agriculture universities, research labs. We do not have a knowledge canals. I'm saying knowledge canal, it is not the one-time advisory. Throughout the year, actionable knowledge should flow to each and every farm. This is a very strong statement. The research question is, how to build a knowledge canal to deliver actionable knowledge to each farm in a regular manner? Or how to build a system where actionable knowledge will be delivered to each farm of India, each farm of India once in 10 days. Imagine if such knowledge is delivered, what will be the benefit? Now you say that, what are you talking? So how can we build such a system? It's a huge problem, huge system, lot of expensive. I will prove that we can build such a system now. But if you observe other domains, since independence, we are trying to provide literacy to every individual, personalize it. We don't question that why everybody has to be educated. It is taken for granted that everybody has to get literacy. Every house should get a road connection. Every individual should have a drinking water connection. Every house has a drinking water connection. Everybody has a skill. Now we are running rural employment guarantee program, skill development program. Ministry is there actually. The objective of ministry is to provide the skill to every individual. Employment. Everybody has to provide employment. Every good should get employment. What I'm saying is that you are doing personalization in all other areas. Why don't you start another project which will deliver actionable knowledge to every farm? So what I'm saying, similarly, you have to provide efforts to provide knowledge to each farm. What will happen if you provide knowledge to each farm? Providing knowledge to each farm will create multiplier effect. It improves water and finance utility. Mostly, it benefits poor and marginal farmers, small landholdings, illiterate farmers. Farm failures will be reduced, productivity will be improved. Communication is not a problem. Everybody has got a smartphone. The question is how to build a system to deliver actionable knowledge to each farm. So, as the answer to this question, I started doing research. The research is how to build a system to deliver actionable knowledge to every farm. The problem is same last 20 years. I started with eSagu, ended with Crop Darpan. I am scaling the Crop Darpan now. So I will explain the eSagu. Then I will explain improvement over eSagu, village level eSagu. Then I explain the Crop Darpan. I hope you might have downloaded some of the app. I hope it is working. If it is not working, let me know. I will ask you. Anyway, I will demonstrate app also. I wanted to translate that app into Hindi. Maybe IIIT Jabalpur can, IIIT DM can help actually. We can work jointly. I will explain you a problem to work with. We can extend to Madhya Pradesh. Here, first project is eSagu. Sagu means cultivation in Telugu language. We put eSagu means e-cultivation, e-farming. So first, I created objective. He said that the system I am going to build, this is 2004 system. The system I am going to build should provide expert advice to each farm, personalized advice. Advice should be provided to between 24 to 36 hours. Advice should be provided once in 10 days. So previous week, next advice should be provided based on the feedback of previous advice. Advice should be provided without farmer asking a question. All good features we kept it. Overall, it should be cost effective, powered by IT. We started in 2004. What is the basic observation? Basic observation is that in medical domain, a doctor examines black and white X-ray and detect the human health problems. I said, this is in 2004. Why can't agriculture experts see the color photographs and detect the crop health problem? So this question is simple now. Now people now think, but at that time they objected, saying that, sir, actually, even we go to crop, we are confused. You are asking us to deliver advice by seeing photograph. But he said that if you do that, then we can build a system. So in this system, eSagu system, agricultural scientist does not visit the crop. Crop photos are brought to agriculture scientists. If it is possible to deliver advice by seeing photos, then I said that scientists can deliver more advices per day, per hour. You can spend less time to provide advice. You can work during the night. I explained all our ideas in one of the current science paper. You can go through it. The question was that at the time there was no internet. Who will send the photographs? The farmers can send the photographs, but it is very difficult to implement. Even now also, you can't expect the farmer to send the photograph. People assume a lot of things, but it is not possible. Because photography is a skill. If you want to get yourself photograph, you hire a photographer or you go to photo studio. Why? Because you think that photography is a skill. And you are expecting farmer to send the photographs. So that anyway, that argument we can argue. But we said that farmers cannot send the photograph because they are not at that level. Most of them are illiterate. They can't operate cameras. So what we did was that we hired educated farmers as coordinators, asked them to send the photographs from the farms of illiterate farmers, all farmers. So this is the system we built. This is the Isago main center. This is the agriculture experts, agriculture information system, which contain crop photos, farm data, farmer data, weather data, soil data. This is the internet communication system. This is the Isago local center. These are the farms. Each coordinator manages some farms. The coordinator house can be a local center. So the coordinator visits the farms every day. He visits today 20 farms, tomorrow 20 farms. After 1 week, he visits again the same farms. Farm cycle. Send the photographs and other information to the agriculture information system. Agriculture experts see these photographs and type the expert advice, which will go to farm coordinator, which in turn the farm. So this is the operational procedure. I submitted a project proposal to Government of India. They sanctioned me about 60 lakhs rupees at that time. I said that I'm going to implement this idea, whether feasible or not, on 1,000 cotton farms in Warangal district. So we selected 3 villages in Warangal district, all cotton farms. So the operational procedure is as follows. We hired some coordinators. We started a computer center in one of the village. We trained the coordinator. Coordinators are educated farmers. Then we have to interview and other things. Then we gave them digital cameras. So coordinator registered the farmer by collecting soil, water, capital, crop details. If one form is given, he fills the form for every farmer. It is uploaded in the server. Once in 10 days, the coordinator visits the farm, about 20 farms. He has a bicycle. He will go to 20 farms. He will spend 20 minutes per farm. Takes problematic photographs. And he also fills in observation cum feedback form and takes its photographs. Upload the data to Isago portal. At that time, what happened was that there was no bandwidth. So in the villages, you used to burn a CD. They used to hand over the CD to the bus at Warangal district. Then in Hyderabad, we used to collect the CD. Somebody goes in the morning, collect the CD, and he used to upload the photos to computer. Then agriculture experts see the photograph and type the expert advice. But expert advice can go online. Dial-up internet was there actually. It was not sufficient to upload the photograph. So this is every 10 days, this repeats for every farm. Today, Monday, you visit some farm. Next Monday, again, you have to visit the same farm, collect the photograph. So every 10 days, advice was delivered to each farm. Suppose I'm demonstrating now. These are the photographs sent by coordinators. These are simple cotton photographs. Assume that I am a scientist. So first photograph, then what I do is that I will click this one. This is a cotton plant growing. This is the zooming. Second, this one, zooming. So zooming is helping significantly, yeah, to the agricultural scientists to identify the crop problem. The zooming, through zooming, scientists can clearly see the leaf as compared to naked eye. So it has a benefit. Third, stem is becoming black. The zooming. Then I told you that already. Coordinator fills in crop observation form. కాండం నల్లగా మాడిపోయి వచ్చినది 50% డ్యామేజ్. వీరు 3 ఎకరాలకు 100 kg యూరియాను చెట్టుకు అతి దగ్గర వేయడం వల్ల చెట్టు మొదలు వాడిపోయింది అనుకుంటున్నాడు. It means that farmer has applied 100 kg urea near to the plant. That's why plant has become black, stem has become black. That's the farmer's perception. Last week advice, stem application, farmer has not carried out this one. In Telugu it is written. This is the advice typed by agriculture scientists. Agriculture scientists typed as follows. It is not due to fertilizer application. It is the root rot disease. So to control this, pour copper oxychloride Blitax 3 gram per liter or carbendazim bavistine 1 gram per liter solution at the base of the infected plant immediately. Then mix 2 kg trichoderma formulation in 50 kg FIM. Sprinkle water on this mixture to maintain the moisture and keep it for 15 days. Then apply in field along crop rows. Tell the farmer to apply 75 kg potash in 3 acre land as early as possible. This piece of advice goes to that farm within 24 hours. And such a piece of advice goes to that farm every 10 days. The cotton, during 8 months, we might have delivered about 20 advices, 20-25 kind of thing. So this is called personalized farm-specific canal. Knowledge, actionable knowledge flows continuously to each farm. This is the next year, government was very happy. They sanctioned me another 1.5 crore, told me to implement this project for 5 crops in 5 different regions. At that time, we implemented this project for cotton crop in Warangal, same place, chili crop in Khammam, that's the chili area, rice crop in West Godavari, that's the Andhra area, and also Rayalaseema groundnut crop. Also, red gram, it is Rangareddy district here near, where red gram is famous. We also implemented a castor near Mahbubnagar. So in this way, we extend for 5,000 farms. The project, we employed about 120 people for that project. Coordinators, managers, scientists. Because one scientist cannot give advice to all the crops. We have to recruit chili expert, rice expert, groundnut expert, all these subject matter specialists. We have to recruit 2 levels. One is BSc level and experience level. So first BSc level will type the advice. Senior expert will correct the advice. So this is the one of the photograph captured from West Godavari. So these are the photographs that come. Advice is brown plat topper, sheath blight, neck blast. Brown tapper, the spray ethofenophrox 300 ml, imidacloprid 60 ml per acre. Sheath blight, hexaconazole 400 ml per acre. propiconazole 200 ml. Neck blast is not low. As the incidence is low, no need to spray. Drain out water and maintain the thin film of water. Direct the spray towards the base of the plant while spraying. This piece of advice goes to rice farm. So there are several things actually. Thousands of farms we provide advice. These are some of the sample photo carton graph. We also implemented for fish also. I hope some of you were interested in this topic. There was a village near West Godavari, in the West Godavari, Patepuram. There are 200 fish ponds are there. 10-acre ponds, 20-acre pond, 50-acre pond. So Government of India told me that, why don't you extend the similar system for fish also? So for fish, what will happen? The fish coordinator manages the fish ponds. When we employ fish scientists here, when coordinator goes to the fish pond, he employs the boatman. So coordinator goes in the boat, catches the fish. Boatman catches the fish. And they capture the photographs of gills and skin. It happened that most of the problems are expressed in the gills and skin. Also, the color of water on the pond. In addition, you'll put some water in the beaker, put the pH meter, and also dissolved oxygen, ammonia. These are some of the 2-3 meters you will put it. You will collect what are the doses you applied, what are the sprays applied, what is the quantity, what are supplements you used. All this data he fills in a form, uploads to the portal. Fish scientist will give the following advice. Flukes and red disease at the starting stage. Apply BKC 80% half liter per acre. Supplement enrofloxacin half gram per kg of feed. This kind of advice goes to that farmer, fish farmer. Another one. This is the previous advice. Again, another piece of this is the skin, and these are some of the photographs. Symptoms of trichodina at the starting stage. Ask the farmer to apply Nuvan half liter per acre. Ask to reduce the feed for 3-4 days. This is the advice that was given by fish scientists. Actually, when we went to the Patepuram village, nobody attended our meetings. They said that, we can't allow you to take the photographs of our ponds. At that time, we worked with Bairaju Foundation. At that time, Satyam Foundation was there. Then through Satyam Foundation, we went to those farmers saying that allow us to take the photographs. If you don't follow advice, it's okay. We want to do some experiment. Then we gave these kind of advices, symptoms of trichodina soil. And after 2 months, I went back to the village. 200 farmers attended a meeting. It means that the technology has the power. Farmer think that they know a lot of, they know a lot. Actually, they don't know. Because they have not done BSc agriculture. They have got valuable experience. But some of they don't have solutions based on experience for all the problems. Of course, they have solutions for some of the problems, not all the problems. They need guidance of the scientists. In this case, the advice was to reduce the feed for 3-4 days. The farmer wanted to sell the fish. It gave more feed to get more weight. Next day, all the fish died because fish were suffering from fever. So these are some of the experiences while implementing the project. Interesting. So then we conducted impact evaluation. Impact evaluation, what we did was that we implemented 3 villages here, 3 control villages. We take the sample and pose the questions, what kind of fertilizers you are using, how many pesticide sprays you are using. We found out that the farmers in Isagu area saved 1 fertilizer bag on average per acre, saved 1 and 2.5 pesticide sprays, at that time 500 rupees per acre, 2.5 pesticide sprays, get 1.5 quintal of cotton extra. Overall, there is 5,000 rupees gain farmers obtained on average per acre. Similarly, chilies also, overall it is same, but only sell price, chili quintal is extra, so 8,000 rupees, 7,885, 8,000 rupees. Paddy, red gram, groundnut, they are not suffering significant problem, but overall they got 12 rupees benefit per acre. On average, overall 4,000 rupees per acre, you can say, additional benefit. So we continue evaluation from every year. We are getting 4,000 to 5,000 gain for each acre. So what are the key results of this project? It went on to 2008 actually. 2004 to 2008. After that, somebody gave fund, state government gave fund, and we tried to run the project, refined it. The farmers are happy with the advice. It is encouraging IPM. We are not saying anything, integrated pest management, because since we are taking photographs every week, we are detecting the problem at early stage. Also, we are not advising over pesticides or under pesticides. We are not belong to organic farming, something like that. We are not saying that if there is a problem, apply pesticide. If there is no problem, don't apply pesticide. So judicious use of pesticides and fertilizer by avoiding their indiscriminate usage. I told you already in the previous turn, the gain is significant, 3,820, 3,874 per acre. So even we cost benefit ratio 1:3, means the project cost and benefit cost. Number of acres multiplied by 3,820, like that. Now, I conducted experiment. How many advices scientists can deliver? By working for 8 hours a day. In the 8 hours, we are removing 2 hours. 1 hour for lunch, another 1 hour for here and there. So totally by sitting for 6 hours, how many advices scientists can deliver? So overall we get 80 to 100 forms per day. About 5 to 6 minutes the scientist will take to deliver new advice. Sometimes he will use the text of old advices, but you have to see the photographs. It takes 2 minutes. Typing takes another 1 minute. Thinking takes another 1 or 2 minutes. So overall, 5 to 6 minutes per advice, 80 to 100 forms per day. You can't imagine a scientist visiting 80 to 100 farms per day. So within 24 to 36 hours, we are reaching the farmers. We also charge the farmers for services and they are satisfied with the service. The charging, I will explain the later. So this is the one of the project I have completed, Isagu. And I'm very happy with the result. Because still I consider Isagu is the solution to India's problems. Because suppose you want to export the farm product. Farm product should not have pesticide residues. How you cultivate without Isagu? Without the knowledge of scientists. Otherwise, farmer will have a lot of headache. He doesn't know whether it is increasing pesticide residue, reducing pesticide residue. So farm-specific advice is required to enable the farmers to produce the crop output with international quality, export quality. So this is the one project. The next is village level ESOP. So the ESOP system, we observed that it is benefit to all kinds of crops. Cotton, chilies, mango, more benefit. Cereals and pulses, less benefit, less problem. The government of India told us that. No, since research is over, now you self-sustain. Self-sustain means collect money from the farmers and if sustains is okay. So then we started charging the farmers. In one village, we said that, okay, pay 500 rupees per farm per season. In the first year, about 200 farmers paid. Second year, it came down to 100. Third year, it came down to 30 farms. So our experience is that about 30 farmers will pay if you start charging because they are serious farmers, they are intelligent farmers. But our objective is to help everybody. That was the beginning objective, to help the poor farmers. Then I thought that, system is not good, not cost effective. Anyway, I talked to farmers. We had a big interaction meeting. I called all the farmers and I had a meeting. Then I asked them, why are you not following this advice? Why are you not registering pay? They told me that, sir, everybody in the village is following your advice. Only thing is that you are sending to those 30 farmers. We are just copying the advice. So this farmer immediately follows what kind of advice coming. Then they purchase some pesticides and fertilizers, the copying going on. Then I said that, okay. I again talked to government. Sir, we developed a ESOP system, why didn't you scale? For example, you are given lot of loans to have horticulture farms, why can't we implement? They said that no, sir, this is not implementable because the farmers, their farms may not exist actually. That's what bluntly they told me. So either it will a problem. So they said that why don't you have a system where farmer name should not be asked? Still you deliver an audit. And also the department told me that, sir, this system is too intensive. It's not possible to provide advice to every farm of India. Somehow you have to optimize it. Based on all the feedback, we worked on next system called Village Level Agro Advisory System. The objectives of this project was that the system should be accessible to poor farmers throughout the year. That cannot be compromised. Should cover all the crops. Personalization also cannot be compromised significantly. It should be affordable, scalable. The criticism for ESOP is that, no, sir, you are giving a advice to directly to the farmer and he is not talking to each other. Community discussion, knowledge improvement is not happening. So this should encourage community discussion, should encourage knowledge empowerment. So the technology is as follows. So we said that let us follow notice board system. One physical notice board is put in each village. Coordinator is equipped with computer, internet, color printer, motorbike. So every 5 villages formed a cluster. Each cluster, we identified 30 sample farms of top 5 crops. So cotton, we said 5 farms for each 5 villages. north, south, east, west variety, black soil 1, red soil 1, all those things. 5 sample farms for each of the 5 major crops and 5 farms for other minor crops. So sample farms will be identified such that they represent all farming situation problems. I hope a lot of scientists in the audience know the name of farming situation. For example, black soil is one, red soil is one. Black soil and variety will be one farming situation. Other variety, another farming situation. Date of sowing changes, other farming situation. So we divide all the villages crops into farming situations. Each farming situation, 1 or 2 farms will select. Then 5 sample farms will be registered for each new crop. So now what will happen? We will ask the coordinator, he has a bike and everything. You go to only sample farms, not all the farms. And capture the photos, send to agriculture expert. Agriculture expert will type the expert advice. And the PDFs of photographs and advice is prepared by agriculture expert. The PDFs are sent to the coordinator or in the directory. The coordinator download the PDFs. By the time the internet we got internet. This is 2010 picture. And he color prints and put the color printouts in the notice boards. Okay. So there's a cotton sheet, chili sheet, rice sheet. We have one big meeting in the village, beginning of the project, saying that the notice board is placed at the center of the village where every farmers cross. For that, we are using the majority voting algorithm. We ask the sample of farmers, again sample, because there is no time actually. Any process in the village should finish within 1 hour. If you start recording it, season collapses because we have a large number of villages, large number of farms. So we ask the farmer, give me at least 3 points in the village where you will visit once. So majority of the farmers will say some point, we'll place the notice board there. And we'll have a big meeting in the village and say that, please see the notice board once in a week, at least once in a week. You can see every day also. So if your farm problem is similar to the photographs on the notice board, you copy this advice. Otherwise, contact us. We will come to your crop and take the photographs. And notice board sheets are changed every 10 days throughout the year. So this is a considered village level knowledge canal. We are using 80% push, 20% pulled by farmer. So sample farms are visited once in 10 days and problems are captured through digital photographs. The farm problems reported by the farmers will be captured. Advice delivery by subject matter specialist through internet. Based on the digital photographs and other information, the expert prepared the agricultural advice to farms. Senior agriculture expert approves the advice. Crop specific advice summaries are prepared for each crop. And the coordinator download the PDFs and take the printout. He got a color printer. Color printer is cheap actually because now the inkjet printer we are using. Then SMS goes to all the farmers by saying that notice board has been changed. So farmers, his job is to visit the notice board and see. So this is the typical notice board. This is the cotton sheet, rice sheet and maize sheet kind of thing. These are photographs, advice. This is our notice. This is the coordinator, cell number and everything. This is about ESOP. This is a brinjal sheet. So brinjal sample farms, scientist prepares, these are the photographs. For the control of stem and fruit borer, apply 3 grams of carbonyl, spray profenopause like that. Weeds are more in the field, with the help of Goru, do the intercultivation. Sucking pest, to control sucking pest, spray dimethoid, something like that. So in this way, this advice, if farmer sees this sheet in the notice board, he is the brinjal farmer. He is also facing the same problem. He can copy this advice. This is in Telugu, local language. This is a maize sheet actually. So this is the maize sheet. So stem borer. So for control of this, page after 3 kgs of carbofuran kind of thing. The paddy, the zinc deficiency. To control zinc deficiency, spray 2 grams of zinc sulfate in only. This is a banana. So they said Telugu. This is in Telugu actually. We gave it to every farm. All the farms. Whichever the top 5 crops we'll do. If the banana crop is top popular, we take sample of banana farm, sample of mango farm. This system is too general. It captures top 5 crops in the 5 villages. This is a chili. The leaf spot is the advice. This is a mango. So this is the zinc deficiency, boron deficiency. One of the retired MLA was interested, implemented. This was the first version of notice board, this aluminum sheet and everything. He implemented one of the KVK and he gave very good results. This is the final notice board, the BEL, Bharat Electronics Limited, the logo you can see. They supported this project under CSR for 3 years. This is the kind of thing. This is the coordinator signature, this is the log and everything. This is the kind of. The Bharat Electronics. So sometimes the sheets are not sufficient. We are pasting on the walls. So farmer has to see the notice board. So actually this project gave some lot of interesting experiences. Every 10 days, the sheets are changed. Suppose there are teachers, take a community of teachers. How many good teachers are available? Very few good teachers. Take a community of doctors. How many good doctors are available? Very few. We are employing good scientists here to give advice to the crop. So this system is creating effect of good scientists visiting each and every village once in 10 days. The farmers are seeing the face of the scientist. Suppose Dr. Narayan Reddy is giving advice and one of the top entomologists in Telangana. And they are seeing Professor Narayan Reddy's face in the notice board. It is as though Professor Narayan Reddy is visiting the village. And the system is very, very cost effective. We computed that about 30,000 per year, we can maintain scientist cost, coordinator cost, everything. And these are the photographs. Illiterate farmers also can understand photographs. And it encourages community discussion. And we are happy with this kind of technology because in Isagu, a scientist can deliver 80 farms per week, 80 farms per day. It means that he will cover 20 villages per day, 20 villages, sample farms per day. 8 days, 160 villages he can cover. 160 villages means huge, 4-5 mandals. Yeah, 6-7 mandals actually. So how many scientists you need? Number of villages divided by 200. And we tried to find some sustainable models at that time. And I was very happy with the system, saying that if some government want to implement seriously, we'll propose this system. The Isagu was there, but that is expensive system. But sample-based thing, It covers everybody. Somebody has to sponsor notice board and everything. This is the one system now available. We know how to implement these things. The next is Crop Darpan. Now, the Indo-Japan project was announced. So I was a partner with IIT Hyderabad. From IIIT Hyderabad, I was a partner. Then Telangana Agriculture University, IIT Bombay. So they told me to build next generation system for the farmers. Because I was known to work on knowledge delivery system. They told me, Krishna Reddy, you are working, build next generation systems. Next generation system, how to build? So people are working on photography based systems. Somehow photograph based systems were not giving good quality. That's what our scientists told. We tested Plantix and everything. We told that it was not working that much because we got scientists. We are checking. So the same thing. Farmers are facing difficulty in acquiring actionable agricultural advice to real-time manner from call centers and web portals. So we wanted to build a system where farmer can identify its own problem. So overall existing systems are divided into three groups. First is pull-based systems, call centers, websites, government starts, department portals. They assume that farmer will ask a question. Whenever farmer asks a question, we will answer it. But unfortunately, farmers are not asking the question. They are not able to ask the question. They don't know how to ask the question. The another is push-based system we designed, farm level system. We said that let us push the knowledge to every farm of India. Farmers are liking, but overhead is high. That's what we found out. As a part of hybrid system, we designed village level system, push and pull. Means 80% will push it to notice board. 20% they have to pull. They have to come to notice board and understand. But what has happened in village level is that farmers are seeing their crop, going to notice board, and going to pesticide shop and calling us and called us. We received a lot of calls to labs from the pesticide shop. The farmer says, sir, I am facing the same problem as is shown in the notice board. Ask pesticide vendor, tell him what kind of pesticide he has to give. It means what? It means that farmer is able to identify the problem, photographs, damage, not problem, damage. There is some damage. He doesn't know the name. He is able to compare the impression he saw in the crop with the pictures in the notice board and he is able to call us. Okay? This kind of experience, we got a lot of calls. I'm going to revisit this one. So the motivation of Crop Darpan is most of the farmers will have high-end mobile phones with internet connectivity, increase the number of educated farmers. So the research question was that, how about building a smartphone application to guide the farmer to identify the field problem and get the solution? So the use case is clear. So I decided the use case. Always in all projects, I decide the use case first. I go from the bottom up manner. Farmer possesses a smartphone and visit the farm. Okay. Because smartphone technology. So you see eSagu camera technology. Village level eSagu photograph, printer technology. We added printer technology. In this one, smartphone technology. After seeing his crop or crop problem in person, the farmer uses the tool to identify the crop problem. What is the tool I'm going to explain? I hope some of you downloaded the app actually. The app is the tool. So we assume that farmer walks in the crop with a smartphone and he is able to, the app will pose some questions, he is able to identify. After identifying the problem, he or she can get the advice from the Crop Darpan and contact any scientist or call center. Advantages. Farmer is able to form a question for his crop or crop problem. It empowers every farmer capacity building. So let us see. What I do is that I will demonstrate this one. Just a minute. What is this? This is somehow. Okay. So can you see the screen? This is the Crop Darpan. If you have downloaded the Crop Darpan, you will get a better screen. This is I'm demonstrating Crop Darpan. I will demonstrate the Crop Darpan and I will explain the logic. I think I will revert the presentation now. Anybody can confirm? Can you see the screen? Hello. Durgesh, are you there? Yeah, I can hear, I think. I can hear.
Yes,
You
sir,
start speaking.
we are able to hear.
Okay. See, you can see the screen?
Yes, yes.
Okay. Then suppose you are a cotton farmer. So this is a screen, you will get it if you download. So now you are a cotton farmer, you are visiting the crop, you are walking in the crop. So this has language also, Telugu and English. It means that we can translate into Hindi also. I'm interested in demonstrating in in Jabalpur also, if Triplet EDM collaborates. Suppose this is a cotton. So there are two options. I know the disease name. I don't know disease name. So if you know the disease name, you have to click this. If you don't know disease name, you have to click here. Now you will get these questions on your mobile screen. Okay. So cotton. So first screen, this one. So you are seeing the crop and confirm these answers. Do you observe any damage on balls? Do you observe any damage on flowers? Do you observe damage on leaves? If the cotton farm is facing any problem, it has to face problem either balls or flowers and leaves or lint. If the answer is no, you can go and sleep well. Because your leaves are fine, your flowers are fine, your leaves are fine, lint is fine. You don't have stem damage. So this works as the audit system. Every day with a smartphone, farmer can walk in the field sample of plants and confirm whether he is facing damage on balls, damage on flowers, damage on leaves or lint. If the answer is no for our question or answer is no for each question, then you can go and sleep well. If answer is yes for one question, suppose damage on balls, some damage on balls, the second level question. Do you find any insect larvae inside or outside balls? Do you find spots on the balls? Do you find any premature shedding of balls? Do you find any fungal growth appear on balls and rotting of balls? So suppose do you find spots on the balls? So do you find any concentric ring brown spots on the balls? Do you notice any dark black angular depressed spots? Yes. You will get bacteria blight, angular leaf spot or black horn. This is a solution. Seed treatment with Pseudomonas fluorescein like that. I will go to again other one because your app interface is very good. So you check with the app. Now only you can download the Crop Darpan app and check it. So now, yeah, suppose you click here. Do you detect any blackish brown colored insects? Grayish brown bug, small pink color thing. So you can say this one. This is the red cotton bug advice, chemical advice. Dust malathion powder around each plant. So it requires only 2 or 3 questions. First question, second question, third question. Or if you don't any problem, you can go and sleep well. So it empowers the farmer to identify. So this app can detect any of the 37 problems of cotton crop. I'm going to show you. Now you see cotton. Now, suppose you know the disease name. Suppose you said that, sir, I know disease name, I don't know solution. If you don't know disease name, it will help you to find the disease and give you solution. If you know the disease name, you have to go to second one. So you get a table lookup. Suppose you know disease name, spotted bollworm, just advise. Spray this one or this one or this one. I think app has got latest advices. So you can see this all advice, all these problems can be detected. Zinc deficiency, boron deficiency, everything. Root rot, mealybugs, dusky cotton bug, refloral, stem weevil, white flies, like this. So you got white flies, this one. So like that. This is done in collaboration with Telangana Agriculture University. They gave these advices. So now you got a paddy. Now I'm releasing the chilies now within next week actually. We can develop for all the crops. Okay. The paddy is, suppose, just a minute. I request you to download and what it is. This one, the website is. Yeah, not fresh. This website is giving some problem, but I hope you understood. We are changing the website also. Yeah, this one is there already. Yeah, this is the, yeah, now you got a paddy. So now you got a seedling problem. Do you have a seedling problem? Yes. Do you find observe spots on leaves in seedling stage of the crop? Do you observe discoloration of leaves at the seedling stage? Do you observe any stems in problem in seedling stage? this one, then you get, do you observe any whitening of young leaves, seedling leaves under the water stress condition? Then it's iron deficiency. So in this way, you can identify any of the problem of rice and cotton crop. So I will go back to logic, how I have built this one. So in this way, farmer possesses smartphone. I hope now you understood what I'm saying. And visit the farm. After seeing the is there a crop problem in person, the farmer uses the tool to identify the crop problem. After identifying the crop problem, you can get the advice from the crop darpan, contact any scientist or call center. So with this empowered knowledge, you can go to pesticide shop. How I got this idea? So I extended the concept from data scientist, database system. In database system, we use the concept of generalization, specialization. Generalization and abstraction, which enables a class of individual objects to be thought of generally as a single named object. For example, your knowledge is organized as a hierarchy. Vehicle can be air vehicle, land vehicle, water vehicle. From generalization to specialization, you ask question. For example, somebody is asking what is the name of the vehicle. Then I will say that, oh, is it air vehicle, is it a land vehicle, is it water vehicle? You will say air vehicle, then I will ask, you will a plane or helicopter? No, it's a plane, you say. It's a passenger aircraft or a freight aircraft. So corresponding attributes, I will ask the question. We play a lot of games, 20 question game. So two children, they play game. One children assume some object, other children has to ask the question. The other child has to say yes or no. So then other child has to identify the name. So it means question answering. Somebody doesn't know object name, but they know how to ask the questions. The another paper we got, visual recognition with human in the loop. So for example, is it chair or aeroplane? You can easily say chair or aeroplane. Is it finch or bunt? Very difficult to say. Because there's a little difference between finch or bunt. For agricultural scientists, for machine learning also, this is very difficult to say. Yellow belly, blue belly, easy for humans. So the question is that, if you ask the object level question, difficult for the human being, but if you ask the feature level question, easy for a human being. Suppose I can ask this object, it may be disease name or it is a bird or anything. You want to give a name. Is the belly white? Yes. Are the eyes white? Yes. This bird is parakeet auklet. Means you are asking question, somebody is saying answer, yes or no. So about crop darpan, so we did some field level experiments. To understand the issue of perception gap of farmers from agricultural scientists, understanding the issue of perception gap of farmers from educated farmers, correcting farmer perception the crop problems and cotton and rice crop. We want to see whether farmers knows the knowledge or not. What we did was that we took the farmers, created some farm. We took the farmers to the field, rice in the village, a sample of 100 farms. Asked the farmers to identify the name of the problem. So we gave this farm, we gave this photograph, we captured the photograph, but farmer, we will not talk to farmer. We will say that what is the problem crop is facing. Then whatever they listed, we wrote here and we entered into database. For all cotton problems, farmer told these words. In these words, you can see it has only perceptions, no crop problem name. Spot tartan balls, holes on the leaves, leaf curling, flower drop, and curling of terminal bud, spots on a ball, white insect. They don't have name of the problem. If you don't have name of the problem, you don't know what pesticide to use. Similarly, all the problems of the rice came down to this one. Reddening of bottom leaves, reddening of leaf tips, stem insect, reddening of leaves, like that. Actually, rice faces about 30 to 34 problems, serious problem. So we observed that a crop suffers from several problems. A field problem is a combination of set of visual perceptions. That's what scientists also do. When scientists go to the field, you will also identify visual perceptions only, most of them. Both farmer and agricultural scientists can provide visual symptoms to each crop problem. Farmer provides generalized visual symptoms. Scientists provide specialized visual symptoms. So what is the main difference? The main difference is that farmer identifies the crop problem with general visual appearances. Several problems map to the one general visual appearance. Agricultural scientists map the problem to a collection of specialized visual appearances because he is educated. So farmer doesn't know specialized visual appearances, he is unable to detect the crop problem. Suppose, take a cotton crop. Farmer is seeing as a leaf curl. Okay? But for scientists, it can be whitefly, it can be aphid, it can be thrips, it can be mealybug, it can be jacids, it can be leaf curl virus, it can be zinc deficiency. Why scientists is saying zinc deficiency, whitefly? Scientist is saying whitefly because he observed the following visual symptoms. He observed leaf curling exists, presence of insects he found, insect color white he found, also leaf discoloration 1, discoloration of scattered irregular 1, and also small insects white flying 1. Due to this 1, he is classifying it as whitefly. He is classifying it as aphid because he says black color insects are there. He is classifying thrips because his presence of white or silvery spots on lower leaves. It means that there is one distinct symptom, distinct signature he wants to confirm. So now all the red ones are mealybug, insect color white in waxy lumps. Jacids, insect color green insect. So we observed that this kind of pattern is existing. Another observation is that, another idea that came to our group, can we form a questions, these features as a questions, ask the farmer. If farmer is able to confirm by seeing the crop, then we can build automatic system to classify those yes answers to problem. We didn't know whether it can work, but we build a system by hierarchically organizing these visual symptoms, and we tested in hundreds of villages. We found that farmers are able to confirm, at least about 30 to 40 farmers in the village. We have shown to agriculture students, MSc students, scientists, international scientists, everybody said that the system is able to help the farmer because they can understand this question. I shown you in the website. Those questions, if you translate to Hindi, it is more meaningful. In English, little bit formal. In Telugu, it is more meaningful. So this is the thing. So this whitefly, aphids, thrips, mealybug, jacids, leaf curl virus, zinc deficiency. So being semi-literate, a farmer is able to identify the generalized. Actually, if you see the village level ISAGU, this hypothesis has been proved in the village level ISAGU. Farmer is seeing the crop, he is comparing with the notice board, and he is going to pesticide shop and calling us. It means what? Farmer is able to identify perceptions. He is unable to identify the disease name. So instead of notice board, what we did, we built an app. That is the difference. Actually, conceptually, village level ISAGU, the notice board system, and the crop darpan is same. Because we are using the notice board for the classification. And here app is, we are asking farmer to say yes or no. So being semi-literate, farmer is able to identify the generalized visual perceptions of the crop. The low-level visual perceptions of the field problems of the given crop can be collected from subject matter specialists. The crop darpan contains a hierarchy of visual perceptions of field problems that consist of generalized, middle level, and low level perceptions. The crop darpan helps the farmer to identify the field problem by confirming the corresponding low level perceptions obtained the agro advice. So this is the name we gave. So what we did was that we investigated visual symptom based generic question answering framework. That's what the name we are given. We are not exploited the photograph. Photograph will supplement later. But with simple question answers, visual perception based. We conducted field study on rice and cotton crop. We developed a workable mobile-based web application of Crop Darpan tool. We refined 5 times actually. We developed a data collection protocol. For example, we develop cotton rice, but we can develop for any crop. Okay, Madhya Pradesh, what are the top crops? We can develop actually. Within 1 year, we can develop and launch and scale it. There is no problem. Then crop problem identification protocol. This is the internal protocol. This is the data collection protocol. It means that if a scientist, if you want to develop a new crop, we'll identify the university. They will assign some scientists. Then they have to talk to us to identify all the problems and perceptions. We'll apply our algorithm, build a hierarchy, and load into the systems. System starts working. That's what we have done for chili. We are releasing next 1 week. So these are the problems that can be identified. Any of the 30 problems can be identified. Any of the 37 problems of the rice can be identified. This is the demo. I already gave you demo. So you have to download the app to the smartphone. Visit the crop field with the smartphone. Open the Crop Darpan app. Select the language and crop. Read each symptom related to question carefully. Observe the crop carefully. Click yes by confirming the existence of the symptom. System will help you to identify the crop problem. And this is not a black box model. So people can understand why it is giving such answers. So I already done. This is the typical interface of app actually. Yeah. This is the Telugu interface we are showing. This is what happening. For example, leaves. Discoloration of leaves, orange, yellowing. It is a branch out. From the leaves, you can see spots on the leaves or discoloration of leaves. Then finally, you have to confirm one symptom. White spots on the leaves. Paddy, panicle grains, fully chaffy grains, brown chaffy panicle, something like. So 3 branches. Paddy, leaves, spots on leaves, dark black to brown particles on leaf, mid to panicle grains. But the question is, farmer enters the crop, you can start from anywhere. You have no problem. You can start with the stem, leaf, flower, fruit. It will branch out and find out the problem. We are not saying that you have to go from the stem, something. It is very flexible. So I hope you like this app actually. And it is very simple, 3 questions, and anybody can play with the app. Flower damage, for example, you identify flower damage question, drying of terminal buds, boron deficiency, spotted bollworm, board square, everything like that. In this way, the trees actually you can see. Balls damage, premature opening of balls, red, spotted bollworm, everything. Cotton, lint damage, lint color damage. So there is a difference between crop and existing apps. Existing apps are photography based. And photography based are not that easy to build. First point, it is not easy to build. A lot of training data is required, and farmer takes photograph in a wrong manner, height and angle, camera quality, pixel quality. It may give you, all are probabilistic based. So the way pictures are taken can result in ambiguous results. For example, pictures of grass taken by very close to it may be confused with the rice plants. This will cause wrong predictions by image-based apps. So, for minute capture, all the same. Some diseases show symptoms on multiple parts of the plant, so difficult actually. The crop darpan emulates the expert. So we just crop darpan acts like similar to the agriculture expert visiting the field. Crop darpan does not need any training. It doesn't have any computational power. For example, if you send the image, you would run machine learning algorithm for classify. The domain expert knowledge is stored in the system used while diagnosis. The current apps only handle the popular diseases. Image-based predictions are probabilistic. It cannot guarantee final prediction. For example, sulfide injury. It is a smell-based injury. Foul smell. So we can ask the question whether you are getting foul smell or something like that. We can exploit all 5 senses and build a crop darpan system. We can put the questions that can be touch, smell, and visual, and like that. The Vijay Mahajan at University of Texas, he came and saw that, oh, very impressive. He then read up on this, give my congrats to Professor Reddy. So he saw this app saying that wonderful app actually. It can be scalable to all the crops, all the farmers, all the regions across India and across the countries also. It is location specific, personalized, language specific, dialectic specific also we can make it. So we are refining it. We can enrich with the videos, images and voice. Protocols can be refined. So we have to develop crop darpan for other crops. If any of you are interested, you can talk to your departments. We can submit a joint project proposal for new crops, start working. Not only Jabalpur, in other states also. To begin with, we can translate this into Hindi to Madhya Pradesh, rice and cotton immediately, 2 months effort. Only we have to just talk to Agriculture University in Jabalpur and we have to talk to one scientist, ask them to go to these advices. If he has any correction, we can correct it. I don't think it is a correction because Agriculture University at Telangana had 20 meetings to give these advices. So I don't think there's any correction. But still, we want to get approval from Madhya Pradesh Agriculture University, then we can start operating. So we can make it more interactive and other things. So the overall conclusion is that crop darpan system has the potential to help poor, marginal and illiterate farmers. It can touch and benefit every family. It can improve the income of poor and marginal farmer, provide cost-effective opportunity to help the farmers. Overall, I feel is that if all states, we develop crop darpan apps for 100 crops, we can create a next agriculture revolution actually. Because gobi, vegetable crops, because they are minor crop doesn't mean that farmers are not having problems. We can build for all the crops, all variations. So it can be a potential cloud computing application. I'm on it. My agenda is to develop for 100 crops in all languages. I request you to join me in doing this work. So collaboration of agriculture universities, IT universities, industry is required. So with this, I stop here. I think it's a long time, 1 hour 45. What is this? 1 hour 45 minutes is over. If you have any, we want to have a discussion. So please, one by one, you can ask the question. I will be able to answer. If you have any questions.
Hello.
Hello. Yeah, tell me.
Sir, good afternoon, sir.
Yeah.
I wanted to know what is the size of this mobile app?
It is very small, I think. Typically, any app, there is no size actually. Here we are not using anything.
What all tools you are using? You have used here?
A modern development stack, full stack that environment we developed.
As I am working in the tribal district, I wanted to know if I want to develop according to their district, how much time on how can I develop with
Which crop? Which crop? Which crop?
Mana millets are there, then maize, Niger, paddy is already you have given.
First medium, actually, we have to, paddy anyway, we have to translate. Tribal, what is the language?
Yes, sir.
First question. We have to identify one agriculture university.
Yes, I'm already working in Krishi Vigyan Dindori, which is being affiliated with JNKVV Jabalpur.
Yeah, we can collaborate. And
Yes, sir.
what we do is that we need money for one SRF. So 2 SRFs will work. And
Okay, sir.
we'll talk to agriculture scientists and we'll identify the crops and we have some protocol. So protocol is that, we'll ask the scientist, please give me list of all the crop problems.
I'm
Visual
having all
symptoms
those technical backups. I'm totally having this.
Yeah.
And what about the sir amount or expenditure which we should be aware?
Yeah. I want one SRF actually, one SRF
Okay, sir.
funding from ITSRF. I need to do actually. That's fine.
And what about the duration?
Duration, let us take 1 year because the question is that within 3 months we'll develop it.
Okay,
For
sir.
new crop, we take 1 year, and for old translation, it will take 3 months actually.
Okay, sir.
So, which language you want to do in Hindi or what?
Hindi.
Hindi.
Or in our local language.
So, which is the local language? Hindi only, na?
Bundelkhandi, I think so.
Yeah, Hindi. So, we'll do Hindi. So, first start translating this rice to Hindi, rice and cotton. And that will take about 3 months actually. And then for new crop, it will take about 1 year. Let us keep 1 year testing another like that.
Yes, sir. Okay, sir. Thank you, sir.
Sir, I think there is no question from our candidate side. They have already completed some in between the presentation. So it's a very nice presentation, sir. Actually, we all are getting something new about the like paddy and rice. Some of our participants are very much interested about the paddy thing. So they also discussing.
Actually, let us develop for gehu, that wheat actually. Wheat crop is similar to paddy.
Yes,
I
sir.
don't know. Madhya Pradesh, they cultivate paddy, wheat or not. I don't know. But
wheat is there, sir, in Madhya Pradesh, sir. We have the wheat.
Okay. Let us start developing it. I hope first impression is that whether they liked this or not. The point is that we develop some app. It doesn't mean that they have to like it. I want their critical feedback. If they don't like it, let them explain why they are not liking. Because we can refine it actually. Because these are the scientists who can evaluate the app critically.
Yes.
Because farmers, they use it, but the scientists, critical feedback is important. We are challenging scientists actually. We are even universities, professors, saying that if the app is not working, let us know. It's not on the face value, you should not say yes, because that's why things won't work. But all are saying that it is working. And I gave a training to about 800 agriculture extension officers, our Department of Agriculture, and they said that we have built an app for agriculture extension officers because we don't know a lot of things. So
Yes.
this app we can use and help the farmers at that level. At least it will work at department level very well, I'm sure, because the extension officer completed diploma, he is able to understand the questions, visual perceptions very well. That was the feedback I got it, and I hope this will, more people will be interested in extending this to other crafts. I'm trying actually. Okay, thank you.
So any other question? No questions? If there are no questions, on behalf of Akshay and myself and Electronics and ICT Academy at IIITDM Jabalpur, we sincerely thank you, Professor, for taking out time. And we wanted your presence. Somehow things like at your place, at our place also, probably. because of
No
that.
problem, madam. Sometime we let us work on this app. Some participant is interested.
Renu is, she is in one of the important centers
Okay.
in Madhya Pradesh. So I'm sure that something can happen
I will
together.
send you this presentation file to you, madam. You can circulate to all the participants and
Yes,
let them get it.
yeah, we are requesting all the experts to share, and so we request you also. Thank you so
Immediately,
much.
I will send. I will send. No problem.
Thank you. Nice meeting you once again.
Okay,
and
okay, madam. Thank you. Thank you.
Hope to see
Thank
you next time at our campus.
Okay, thank you, madam. Thank
You
you
have
very
not
much.
visited our campus now, so it's high time that you visit
Yeah,
us.
yeah. Thank you. Thank you. Thank you.
Thank you, sir.
Thank you. Bye.